We are going to solve a problem that requires determining the theoretical yield before calculating percent yield. Our problem reads, chlorobenzene, C6H5Cl, is used in the production of chemicals such as aspirin and dyes. One way that chlorobenzene is prepared is by reacting benzene, C6H6, with chlorine gas according to the following balanced equation. So our equation is balanced already, which is great. And our first question reads, what is the theoretical yield of C6H5Cl, which is the chlorobenzene, if 45.6 grams of benzene react? So to determine the theoretical yield, we have to set up our stoichiometry problem by writing the given and the unknown above the balanced equation. So from our problem, our given value is our 45.6 grams of benzene. Above benzene, I'm write 45.6 grams. And then our unknown is our chlorobenzene. So above chlorobenzene, I'm going to write X grams. Now, because we're working with grams, that does mean we have to determine the molar mass of both benzene and chlorobenzene. So for benzene, which is C6H6, we have to determine our molar mass. So we have carbon and hydrogen. Carbon, we have 6 times the mass of carbon, which is 12.01. When you multiply that, you get 72.06. For hydrogen, we also have 6 times the mass of hydrogen, which is 1.01, and that gives us 6.06. And then we add those two numbers up for a grand total mass of 78.12. And that is our mass of benzene that goes underneath our benzene, 78.12 grams. So now we have to solve for the mass of chlorobenzene. So we have our chlorobenzene, which is our C6H5Cl. So for our carbon, we have 6 of them times the mass of carbon again, which is 12.01, and that gives us 72.06. Hydrogen, we only have 5 this time, times the mass of hydrogen at 1.01, and that equals 5.05. And then chlorine, we have 1 times the mass of chlorine, which is 35.45. And that equals itself 35.45. And then we add those 3 numbers up for a grand total mass for chlorobenzene of 112.56. So that is the number that goes below our chlorobenzene for our proportion. So 112.56 grams. Now we have everything that we need to set up our proportion. So we have 45.6 grams over 78.12 grams. And that equals X grams over 112.56 grams. So we cross multiply this way, and we get 78.12 times X equals, we cross multiply the other way, and we get a really big number, which is 5,132.736. Now to solve for X, we divide both sides by 78.12. And that gives us X equals 65.7, which has 3 Sig Figs, which is what we want, grams of C6H5Cl. And that is our theoretical yield when our mass of benzene, which is 45.6 grams, reacts. Now, once we find our theoretical yield, we can then calculate our percent yield, which is what we're going to do next. So our question B says, if the actual yield is 63.7 grams of chlorobenzene, calculate the percent yield. Now, remember, our formula for percent yield is actual over theoretical times 100. So our actual yield for this problem, our actual yield is 63.7 grams. So we have our 63.7 grams divided by our theoretical yield, which is what we just calculated, at 65.7 grams, multiplied by 100. So when we calculate this out, we get a value of 96.9558. Now, with that, we have to account for Sig Figs. So from our numbers used in our problem, we need 3 Sig Figs. So when we're looking at our answer of 9, 6, 9, those are the 3 Sig Figs we want. We look at this 5, and it's going to round our 9 up. Well, in that case, the 9 will then round that 6 up and become a 0. So our final percent yield for this problem, our value is 97.0 for 3 Sig Figs percent yield. And that is our percent yield of chlorobenzene when 45.6 grams reacts and we only get 63.7 grams produced from the actual reaction.